Hello friends, this is a computer network class. In previous class, we have learned flow controls and different types of ARQ, different types of flow control protocols, sliding window protocols, go back and RQ, select and repeat ARQ. Now the times to come, media access control. Okay, so here first we see line configuration, types of connection. Here the point-to-point connection means there is a dedicated link between devices. Means that there are two devices, device 1 and device 2, the host 1, host 2, and they are connected with one single channel which we have wire or link. And for point-to-point communication, we have learned flow controls. In flow control, one host and one receiver, transmitted and receiver, and there is a data transmitted from host to receiver and receiver to host. There is no another host between this link. Okay, so here is the point-to-point means one host and one receiver. There is no any other host between them. Now multi-point also known as multi-drop. Here we will learn media access control, flow control for point-to-point channel, and here the media access control. Media access control, there is a one single host and many other receiver host. Means that one channel here this is a channel. This is a channel, and there is a multiple host or receiver, you can say. This is also called broadcast media. Broadcast media means there is one sender. If this host send the data to the other host, received by the other host, means there is one host and all are receiver. Here the best example is bus topology. In bus topology and wireless medium, or as a internet or Wi-Fi, we send a packet to the internet. There is multiple receivers will receive the packet. Okay, now here in data link we have learned framing, error control, and flow control. Flow control for point-to-point link. Point link is their physical link, means there is a cable between two hosts. This is a physical link, which be a cable. When there are two hosts are connected with the cable, this is point-to-point link. Now here the access controls, the access control must multi-point. Okay, now in data link layer divided into two sub layers: logical link control and media access control. In media access control, here means that here the network layer, here the physical layer, and data link layer is divided into two parts: logical and media. What is a logical link? It is our sublayer, upper sublayer of the data link layer, responsible for data link control and flow and error control. So in logical link control, there is a flow and error control. Okay, we have learned flow control and error control topics previous lectures. Now here the second layer, media access control. In media access control, it is a lower sublayer layer, and it determine who can access the media. Means that if there is a host and there is another host, this channel, and there is one host and many receivers, means that in this channel at a time only one can send the message. So it determines who can access the media. Multi-point multi-drop line configuration means that we will learn here, if one host send the data to the channel, then they have to get the access of that channel. So it determines who can access the media or channel. No use in point-to-point line configuration. So the media access control is not any use in case of point-to-point line configuration. ठीक है, मल्टीपल एक्सेस कंट्रोल्स होते हैं So first we'll have MAC address. What is MAC address? It is identification of the source and destination node of the packets. So the MAC address is a identification for the source and destination nodes. It is a physical address. MAC address is a physical address, means it is the address of hardware. You have in all device have an IC card, network interface card, through which device make the communication with the other host. So each NIC card have its unique address called MAC address. The MAC address is a 42-bit or 66 byte. The MAC address is of 6 byte. It should be unique between the network. Means that if you have a network, so it should be a unique within a network. Although MAC address is a unique for all devices in the world, all these many devices, millions of devices, and these have millions of devices. All devices have unique MAC address. The representation of MAC address. In binary representation, there is 48 bits in MAC address. Okay, 110001, whatever the MAC address is. In hexadecimal representation, this is a form in which MAC address is represented. In his special MAC address, broadcast MAC address. Here, the 11111. If there is MAC address is 111, but is called special MAC address, and it have a special purpose. Means that special MAC address is not an address of any device, but it is a special type of address, MAC address called broadcast MAC address or special MAC address, which is 42 bits 1. Okay. Now the interference means that two or more nodes transmit the packets in a same time, simultaneous, called interface. And the collision, if two or more signals at the same time, node receives if node 1 and node 2, if you have a node receives packet 1 from node 1 and a packet received from node 3, two packets are received at a time. So what happens? There is a collision. Distribution algorithm determines how the nodes share channels and when node can transmit. These are the two things we have to determine: how nodes share channels. Which channel is there is a single channel, so how nodes shares channel, and determine when nodes can transmit. Okay. Now here the MAC protocols are divided into 3 categories. Media access control protocol is divided into 3 categories. First is channel partitioning and random access and taking ring. Okay. Taking turn. The channel partitioning is a part of physical layer. Okay. And which random access, here we learn random access, and taking turn is not in GIT syllabus. Okay. Here in channel partitioning, it is a static allocation. Means that in static allocation we allocate the time or tokens for the channel partitioning. Means that if there is a channel, now in channel partitioning it is a static allocation. Means that we allocate the time. Means with that we can allocate the time. We allocate the channels to the host, like we allocate on the basis of time. so that from this time to this time this host will transmit the data, and from this time to this time this host transmits the data. Means that we are here in static allocation we fix the time for each host. For each host we assign the time. At this time this host will transmit the data into the channel. Okay, in static allocation. In random allocation we don't allocate any time or anything. If any host have data to transmit, then it transmitted. So here is the chance of collision. So here is a chance of collision means that if any host want to send the data, then it transmits into the channel. This things happens in random access. In taking turn, there is a dynamic allocation. Dynamic allocation means if there is a channel and any host send to data to the channel, then if the channel is not busy or channel is free, then the host can send the data. But if channel is not available, then it wait for its chance to send the data. Okay, in here there is a fixed time. This is a random, so chance in collision. Here get the chance by the availability. If the channel is available, then get the chance. If not, then not get the chance. So here the chance of collision is not happens. Here the chance of collision not happened. In random allocation, the chance of collision happened. Okay, here the channel partitioning, channelization protocol also called it's also called channelization protocol. Here the channel divided into smaller processes. As I know, here the basis on time slots and the basis of frequency. We can divide the channel on the basis of time slot. Each host, we give each host each time. We provide a time at which only this host can transfer the data. Okay. Allocate piece to node for exclusive use. Okay, here we allocate the node piece of channel to the node. Now the channel partitioning having protocols, time distribution, multiple access. These are the protocols in channel partitioning: TDMA, FDMA, CDMA, frequency division, multiple access, code division, multiple access, and time division, multiple access. Okay, we don't go details in these protocols. These are the topic of physical layer, and physical is not in our gate syllabus. Now the random access, which is a part of our syllabus. So in random access, channel is not divided. Here we don't divide the channel into the time slots or any other method in other parameters. Unlike channel partitioning, when the node has packet to transmit, it transmitted. In random access, there is a protocol. So these are the protocols of random access. Here the Aloha and CSMA. Aloha for satellite communication or wireless. The Aloha is good for satellite communication and wireless because in Aloha, if there is a Aloha protocol, then any host want to transmit the packet, it transmitted without knowing about channel's condition. Channel is free or busy, whatever. So here the Aloha, which is for long communication, wireless communication or satellite communication, because here there is no any specific channel. So that's why Aloha is for satellite communication or wireless communication. Now CSMA carrier says multiple access. Here in CSMA, before transmitting the data, transmitter sends the channel is busy or not. So this is a CSMA. In CSMA there is a CSMA CD and CSMA CA. It is mostly used for wired media. This is for wireless media, for wired communication. In wired we can sense the channel is busy or not, because there is wire there is a limited number of hosts. Now the taking term. Here is a channel partitioning random access. So in channel partitioning static allocation होता है, ठीक है, no chance of collision, okay. Efficient at high traffic load, insufficient at low traffic load. Now random access, no any allocation, chance of collision, efficient for at low traffic, insufficient at high traffic. Okay. Now the taking term. Now taking term is a control access protocol, channel allocated explicit, no chance of collision is also here, and the dynamic allocation. Here the control access protocols of taking ring is the reservation, pooling, and token passing. These are the protocols of taking turn. Okay. These are the protocols of taking term, media access control, reservation, pooling, and token passing. Here some standards. IEEE standards. IEEE 802.3. The Ethernet standards protocol. Here IEEE 03 is the Ethernet, which work on bus topology, and here which work on bus topology, and the protocols use CSMA CD. Now IEEE 802.4 is a token bus. It is a bus topology. Topology used bus topology, and the protocol is token. Token method is used. Token passing, which is part of taking turn, token passing. IEEE 802.5 token ring. It also used ring in ring topology. It also used in ring topology, and here is also a token passing protocol is used. Now IEEE 802.11 is the it is for wireless or Wi-Fi standards. Wi-Fi standards, and the protocol used in this is CSMA CA. So must remember that IEEE 802.11 is a standard for wireless or Wi-Fi. Its protocol is CSMA CA, and IEEE 802.3 is a standard for Ethernet, and it's a bus topology, and it's CSMA CD. You must remember CSMA CD for Ethernet and CSMA CA for wireless. Okay, thank you.